I'm going to go through the entire final exam review. I'm not gonna do it with integrity, I'm gonna do it with, either explain everything or show me, and I'm gonna post you the link to the video, and it'll either be in Show Me or it'll be on YouTube. And I'll give you the exact link, and it will be me working through the whole entire final exam review step by step. So even though you've got the key, I will still work through it for you.
Well, that study guide is actually from the old study guide. The answers on
The
that.
answers are on the old study guide to everything except maybe this one. I'm not sure if this one's
That's what
on.
I'm saying, it's
The
the answers
answers
to
on-
the old study guide, not.
Well, but the problems on the new study guide are the same pretty much as the problems on the old study guide. They're a little numbered a little differently. And what I'll probably do is I'll go through working, and that's what I'm saying, I'll go through and work the new study guide step by step. Okay? That way you'll still have a way. Just knowing the answers to it doesn't necessarily always help you. You need to hear, how did you get
Well,
that?
that's why, I mean, I'm going back, and I'm like, okay, since it was for more at the beginning of the semester, I'm like, I forgot to do
Yeah,
this.
that's why I'm gonna make a recording for you, and I'll send out a link to everybody and remind, so you'll have time to do that.
Can I sign up for that again? So
For Remind?
I'm never I signed up for it, but I never get the messages. So I don't
Okay, I have no idea, but,
know. Or could you possibly email it to you to
I can email out the remind, I can email out the link through D2L2.
All right.
Yeah, I'll do that. That way you'll get it both ways.
The final exam notes that have the answers,
Mm-hmm.
where do you get that? Because I can't.
It's in D2L and it's in Shobi, both. Well, not in Shobi, it's not in Shobi yet.
Okay.
It is in D2L.
Where at in this year?
Under content, under final exam review.
Okay.
And both of the reviews are there, plus the answers to the old one, because I didn't have the new, I hadn't had a chance to make up the new one. I didn't get it till the last time we were here in class together.
Under what?
Content,
Okay.
okay? Okay, so let's talk about how we do this problem. And then, again, there's a tutorial for how to do this, so don't forget that that's in your Tools for Success and my math lab. But what you do basically on this problem is, and maybe it would help if I actually will put it up here and I'll write the steps down too. Okay, what we're going to do is we're going to put this data into list 1 and list 2 of your calculator. So fees are going to go in list 1, revenue is going to go in list 2, and the way that you start out is you press your stat button, and number 1 is edit. That's what you want to choose. And you're going to enter the data. So that's what we're going to walk through right now. So get your calculator turned on, you press Stat and hit Enter at Edit. And then in List 1, you're going to put your fees. And if it drops off decimals, if it drops the decimals where it's decimal 00 like the first one, that's okay. The first one is $9, $9.75, $10.50, $11.25, $12, $12.75. And then we're going to put the revenue in list 2. And that's $20,000, $20,400, $20,310, $19,730, $18,660, and $17,100. Make sure your lists are the same length. It's very important. They have to be the same length. And then you press your second quit to leave there. That's your second in your mode button. And then you press stat again. And you're going to right arrow to calc. And you're going to go down to where it says number 5, quadratic regression. And I've actually showed you that there on the study guide. And if you're given one that's not going to be quadratic, just look for the one that matches the kind of model it says to have. Quadratic regression is quadrag. Cubic regression is going to fit a cubic equation. Quartic is going to fit a fourth power equation. That's linear regression. LN regression is natural logarithmic regression. You're not going to have one like that, I don't think. And 0 is exponential regression. So if it says fit an exponential model, then you go to EXP regression. And if you have a question about that on the final exam, about which button do I need to go to, you can come up and ask me. I'll tell you that, because that's not really something you've had a lot of practice with, so it's easy enough to forget. So I'm going to go choose my quadratic regression and tell it that my x's are in list 1, so that's second and L1. And on the TI-83, you have to have a comma. On the TI-84, there's a little table that comes up and asks you the various questions. But it's the same answers in a different order. You just don't need the commas. So the second thing, your Y list is second L2. If yours has something about a frequency distribution, leave it alone. Skip over it. And go down to where it says store regression equation or store equation. We want to put that in Y1. So you press your vars key. You go over to Y-vars. You choose function and you choose Y1. Now I'm going to write down the key steps for that. Okay? So that way you'll have all your steps written down. And then all you do is hit enter. You left out a comma, or you maybe put one too many in. Okay, you've got one linear regression. You don't want linear regression. So just delete that first. Okay, that's all. Everything else is fine. Okay? So what this tells me is that my regression equation my model for this problem is, let's see, this is a revenue model, so I'm going to call it R of X. And R of X is equal to negative 435.55. And that's going to be X squared plus 8,700, and that's going to be X, minus $23,020. And I know it's dollars because it says revenue, and it says the table gives the average weekly revenues for delivering letters for various fees, and these are all in dollars. So this is dollars revenue.
Would it be
Point. Oh yes, it should be 56. Thank you. Should round properly. So it's dollars revenue for X dollars in fees. So this is the equation, and then you have to have your units. Dollars revenue is R of X, and dollars in fees is what represents your X. And apparently I put G of X there, so this should have been G of X. I'm not going to count off if you use a different letter from what I do. And it says use the model to estimate revenue if the fees are $11.75. So what I'm going to do is I'm going to take that model and I'm going to plug in $11.75. Now I can do that by going through the arithmetic, that's fine, but there's a little shortcut if you want to use it. All you do is you go back to that VARS sequence. Right there on your home screen, go through the same sequence you used to get your Y-VARS, and you go VARS, Y-VARS, function, Y1, and then you put parenthesis 11.75, close the parentheses, and it will actually do the arithmetic for you.
I'm sorry, can you go back to what you just did?
Okay.
So you hit, when you were on that screen, you hit bars, Y bars?
Function, Y1, and then in parentheses put 1175. Okay, and then when you hit enter, it gives you the answer, which is $19,071 and 11 cents. Now, if you want to do it by the arithmetic, what did I mess up? Negative 435.56 plus 7. That should have come out to be the same.
Thank you.
What did I, does anybody see where maybe I've typed in something wrong?
Like, do we get a negative number?
There's a negative number right there in the very front, but it's multiplied times this squared.
I put the whole equation in and I got a negative number as well, so I just broke it down. I don't know why my calculator did it wrong. Put everything.
I got the same, I got 19.
I got 19,007.
You're supposed to be negative 23,020.
Ah, yes, okay, okay. So that should have been subtraction, because they should come out with the same answer. Thank you. I kept staring at it and just couldn't see it, so thank you, Jan. There you go. Now, it does come out a little bit different on the change, and either answer is perfectly fine. It comes out within $1 of each other. The difference in the two is because if I do the Y1 with the parentheses, it uses all the decimals. If I type in the rounded off coefficients, it rounds off a little bit inside the equation. So either one is just fine. So if the fee that's charged is $11.75, then the revenue generated will be $19,071 roughly. We would round that to the nearest dollar anyway. Because if you look in your original data, they've rounded all of those off to the whole dollar, and both of those would round pretty much to $19,071. Okay? Find the next page. I'll come look at it for you. Hang on. Pause this so it's not in the recording. Anytime you're going to graph anything, you go to your calculator and you press your Y equals button. Can y'all still see the right? Okay. Press your Y equals button, and we're going to clear out what's in there because we don't want that equation. We want this new one. And our equation is x to the fourth, so you press your X, and then your caret above your division sign is your power key. So x to the fourth minus 7x squared, and you can either use x squared or you can use your power key and a 2, whichever one you want to, minus 8. And then we're going to set the window to the standard window to start with and just see what we see. So rather than try to set it up for something, we're going to press the zoom key and go down and choose number 6. So what we've done is we've hit y equals and put this in y1. And then we hit zoom 6, which is your standard window. Which basically is from -10 to +10 for both x and y. And what happens when we see that window is we see that it comes down, and we see that it goes up, and we see that there's a little loop here. So apparently there's something else down toward the bottom, Y-min, that we're not seeing. So we want to change the Y-min to a smaller number. So we're going to just move Y-min down by, oh, let's say maybe 10, and make it be -20. Just to be sure we can see everything this function's doing. So now we go to the window and we go down to Y-min and change -10 to -20. And then you hit graph again. And now I can see everything that function's doing. Okay? So it says where are, excuse me? Hmm? Do you have an 83 or an 84? Okay. This is how you would have to do it on the 83. The 84, one of the 84, the newer 84s actually make the exponents for you when you hit that caret sign. So the caret disappears and it makes it into an exponent. It's kind of like what my MathLab does. So the first thing to do is make sure you've entered in your equation correctly. But then once you get that, here's your graph.
I forgot the windows.
Okay. So there's your graph. Now it says, where are the x-intercepts? Well, I can look, and it looks like the x-intercept is at about -3 and about +3, but I don't know that that's exactly what they are. I can't tell if that's exactly what they are. So what I'm going to do is I'm going to go second trace. We did this last time. And I'm going to ask it to find the zeros. And if you remember what you did when you're trying to find zeros is you have to get to the left and to the right. And if you can see, my cursor's right there. If I move it one more, it actually jumps below. So I need to actually be above the x-axis because it's going above and then below from left to right. So I start out there.
When I hit second trace, am I hitting the number 1 for the value or 2?
2 for the 0. 0 is equal to your x-intercepts. X equals gives you the value, x equals 0 to get your y-intercept. So we're going to get the x-intercepts first because that's what it asked for first. So then we move it to below the x-axis and press enter again. And notice you see your two little things pointing at each other. It's not doing that? Okay, let me give you a different approach because this always works. I showed you how to do this last time, but what we're doing here last time. Let me show you another way you can do it. Let's go back to y equals. And at y2, put in y2 equals 0. Okay? y2 equals 0. Okay? And hit graph. Now, you're not going to see it graph any differently. What is the equation of the x-axis? Y equals 0. So now I've got a line going through the graph at y equals 0, and then I've got my quartic function, my fourth power function, on the graph too. So now I can just look for where those two intersect. And I know y'all know how to do that because that's much easier. So we will go second, trace, go down and choose number 5, intersection. Trace over close to where we think it is. Of course, we can't get there exactly. And then hit enter, and notice that it jumps then to y2 equals 0, which is right on the axis. And hit enter again. And then enter one more time and let it guess what that x-intercept is. And the x-intercept is, now we're going to have to round that off because it didn't come out even. Yeah, that's a good alternative way to do it.
Is it negative 2.82?
I wouldn't call it negative 2.83. Although when we get ready to graph it, negative 2.8 is going to be about as close as we can get.
When when I did it like the other way we've been doing it,
Mm-hmm.
the y for it, it says is like 1e to the negative 12.
Yeah, let me show you that one so that you, in case that were to happen to you, that you would be able to understand what that says. So I'm going to go back and do it by the zero method. Now notice that your answer on your x is pretty much the same, negative 2.83. But this says y equals 1e negative 12. So in order for you to understand what that means, you got to remember your scientific notation.
How did second trace intersect?
So you wouldn't assume.
Yeah, you'll get exactly zero if you do where they intersect.
So you wouldn't assume it's 0.
You would assume it's zero, but this is why you would assume it's zero. And that's supposed to be a 10, sorry. So that's 1 times 10 to the negative 12. And if you remember scientific notation from a long time ago, that says that what you do is you have your decimal after your 1, and because that's negative, you're going to move that decimal left 12 times. So that means you're going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 zeros. So if I've got decimal 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 1,
Pretty much 0.
that's pretty much zero,
Yeah.
okay?
All right.
Now, what did you do? Second trace what?
To get the one I got, I use the method I was showing you first. To actually find the zeros, you go to the left of it and to the right of it, and then hit enter and let it guess at where the intersection is between those two.
Yeah,
But if you,
second trace what? I can't remember.
0. Okay? So if you use that method, you'll get something that looks kind of strange, but anytime you see E with a big negative number after it, that's 0. Okay? So now we'll find the other one. And again, because we've got the equation of the x-axis in here, we can just do that by finding the intersection point. But we have to trace close to the one that we want it to find. Otherwise, it'll find the one it's closest to. It's like us, it's a little bit lazy. So now that I'm close to what I want it to find, I'll hit enter 3 times. And it says the other one is positive 2.83, 0. Okay? And my y-intercept, if you remember, all you do to find your y-intercept is go second trace and choose value and tell it where is x equal to 0. Because that's what your y-intercept is. It's always saying if x is 0, what's y? And it says if x is 0, y is negative 8.
Can you just tell me how you got that x to equal 0? What did you do?
You hit second, trace, and just choose the very first thing, value. And then you plug in 0 for the x. Okay? Now, one thing that you want to notice, because once again, we've talked about y equals mx plus b. B is the y-intercept. Well, if you've got a polynomial equation and you let x be 0, both of those are going to disappear, and your y-intercept is actually just sitting there in the equation. So you can pick it off if you don't remember how to find it on the calculator.
So this is like that problem we did for 28, I think, where we did a varying range and the one.
Mhm.
Yeah.
And in fact, it wouldn't hurt to talk about, what is the, even though it's not asking on here, let's talk about this. What is the domain for this problem? Are there any X values that you can't put in? Or is there any X's that will cause you to either divide by 0 or would cause you to take a square root of a negative number? Are we dividing by X anywhere here? No. You see any square roots? I don't see any square roots. So therefore, the domain, they ask us this, would have been negative infinity to infinity. Or if you want to write it in words, it's all real numbers. Okay, that means the same thing. Now, if I were to ask you for the range of this problem, that's the y values. And the range is not negative infinity to infinity. And here's how I know it's not. I'm going to go back and adjust my window just a little bit more, just so that you can see what I'm doing here in a second. Does that graph have a bottom? Ah, it has a bottom. It only goes down so far, so it doesn't go to negative infinity, does it? It goes to positive infinity,
Right.
and it's an even function because its arms are both up. Anytime they're both up or both down, it's an even function. But if it's an odd function, that's when its arms are out of whack. They point different directions. This one, because it points up in both directions, that changes its domain, and it does go to positive infinity. But it doesn't go all the way down to negative infinity, so what we need to know is what is that number right there and what is that number right there, the X values. We need to know the minimum values. So what we do is we once again go to trace and choose number 3, minimum. Move your cursor to the left of the bottom of that graph. And it doesn't matter how far to the left, you can go really close to it or you can go further up, but just make sure you're moving to the left. And then it says go to the right. So you trace on over toward the right until you can see that you're very definitely to the right side of where the bottom is. And then you hit enter again. It's the same thing as finding the x-intercepts. And then it says it wants to guess, so let it guess. So it says the minimum is at negative 1.87 for that one. Now that's the y value, so the x value would have been, I'm sorry, that's the x value. The y value is negative 20.25. And that's going to be more the number we're looking for here. Now we also need to find the other one to make sure that it's not maybe even a little bit lower. But it is the same, you're right. We go second trace, go down and choose minimum again, and move over to the left of the one we want to find. You have to be close to it. And then go over to the other side of it and press enter. And we get the same answer that we did before, except it's a positive x value.
And for the maximum, it would just be infinity.
The maximum, there is none. It actually has no maximum value because infinity is not really a point we can write down. So we just say it doesn't have a maximum. It goes up forever. So its range then stops at negative 20.25.
Oh, for some reason, I'm getting
To maximum, you did go into second trace and you did minimum again.
Relative maximum, there is none. Because it has a bottom, but it has no top. It just keeps on going and going and going like a tree. It grows forever. Okay? Now some functions have a top, they don't have a bottom.
Okay.
That means then that they would have a relative maximum, but no relative minimum.
So,
And then your range would be affected by that. Question?
So what I'm saying, the minimum, that's just saying where is it limited?
Yeah, where is it limited? It can't, where can it not go any further below? Okay?
So you
Where
would
does it
want
have-
us to, for like relative maximum, you wouldn't want us to find the point that, where it kind of, like, the way the graph goes, the, point where it raises up, wouldn't that be a relative maximum, not an absolute maximum?
A relative maximum would be if I just, and that's a really good question, Scott. The relative maximum would be if I were to tell you on the interval from 0 to 5, what's the relative maximum of this function? Then you just have to plug in 5 because that would be the highest number in that interval. But it has no absolute maximum, you're right. It keeps on going forever. And that's why both of those say relative. Because it doesn't even have a relative maximum because I didn't give you an interval to put it on. Okay? Now it also wants you to graph this function. You've got all the information you need now to graph it. Since you know that it had to go down to about -25, then you're going to want to put -25 down here. And our graph goes up to about 10. Now if this is -25, then if this were, let's see, how far can I count and make this work? Let's call this -20 and call this -10. And then that would make this 0 and this is +10. So if I draw my axis there, I'll be able to get in all of the graph. And so this is going to be my x-axis then. So then I'll put in what I know. I know that my x-intercepts are at about -2.83, and I'm just going to count these by ones. So this is -1, -2, -3, and so forth. And notice you don't have to scale your y-axis the same as you do your x-axis. They can be scaled differently. So -2.83 would be -1, -2, and about that far. And +1, +2, and about that far. And then I know that my y-intercept is at -8. And if this is -10, -8 would probably be about there. So I'll label my points. And then I also know from what it's told me that my relative minimum is at about -1.87 down to about 20.25. So I'm going to go not quite to 2 and then go down to 20 and just below the 20. And then do the same on the other side. And then I'm just going to connect up those points as best I can. So I know that it comes down, and then it goes back up to this, and it comes down again, and it goes back up to this, and then from there on it just keeps on going up. So you just use your calculator as a guide, plus all the information that you've picked off and put in about your graph. And we're gonna do the same thing with a couple more so we practice a little bit. Okay? So going to number 24, in number 24 we have what's called a rational function. It's a fraction. And here we do have a problem as far as the domain goes because we're dividing by x. And there are potentially some x values that would cause that fraction to have a zero denominator. So we need to figure out what that is. So the question then is, where is 4x squared minus 4x minus 3 equal to 0? Now you can do that algebraically, or you can graph it and find out where it has zeros. But I think it's worth knowing how to find it algebraically, just in case you ever need to. So what we're going to do is use something called the quadratic formula. You will be given the formula. You do not need to memorize this formula. The quadratic formula is x equals the opposite of b plus or minus the square root of b squared minus 4ac, all divided by 2a. And it looks complicated, but it's just arithmetic. And what you need to know is that this is a, this is b, with the sign, don't forget your signs, and this is c. So every place you see b, you put in -4. And every place you see a, you put in +4. And every place you see c, you put in -3.
This is negative b, wouldn't it be positive?
Yes. Now I'm going to go back and I'm going to bring in my, remember it's the opposite of b, plus or minus the square root of b squared minus, there's supposed to be a 4 in there, so that's going to be 4, and I'll need to put in my -4 again. And my -3 out here. I didn't leave me enough room. So that's -4 times a times c. And let's see. No, that's not 4, that's 2. Sorry. Sorry, my bad. That's 2. No, it's not. It's 4.
Yeah.
Need white out. And that's all going to be divided by 2 times 4. So I need to do a little arithmetic here. Now the part of this that's the hardest is the part that's under the square root. The square root, what is, and without using your calculator, I want you to use your brain here. What's -4 times -4?
16.
Good. That'll, if you'll just not try to do everything on the calculator and try to do some of this actually with common sense, you won't make the mistake of saying that's -16. Because if you're not careful how you enter your calculator, you're going to get -16. And then minus, I've got 4 times 4 is 16. And 16 times 3 is 48. And that's -48.
Yeah, it would be a positive.
But it turns into +48 because you're subtracting -48. So this is the square root of 16 plus 48. And the only reason I went through that is to keep you from making mistakes that I know people make all the time. So the way you should put that in is parentheses, -4, close parentheses, raise it to the second power, put the 4 in there. Minus 4, and then in parentheses, 2, parentheses, and in parentheses, negative 3. And it says it's 40. And I know that's not right, so let's see, negative 4 squared minus 4 to I. Still trying to make that 4 into a 2. So it says it comes out to be 64, which if you take 16 and add it to 48, you do get 64. What's the square root of 64? It's 8. So I have the opposite of negative 4 is 4 plus or minus 8 divided by 2 times 4 is 8. So 4 plus 8 is 12 over 8. 4 minus 8 is negative 4 over 8. And if I reduce the fractions, that's actually negative 1/2. And let's see, 4 goes into 12 3 times, and it goes into 8 2 times, so that's positive 3/2. So there's 2 x values that would cause that rational expression to be 0.
Why are you putting that over 8?
Because 2 times 4 is 8. That's part of your formula. So I know that 4x squared minus 4x minus 3 is equal to 0 if x equals 3/2 or negative 1/2. Either one. That's a problem. So in my domain, what I have to say is my domain goes from negative infinity to negative 1/2, and from negative 1/2 to 3/2, and then from 3/2 to infinity. But this is telling me that I can't choose either negative 1/2 or negative or positive 3/2, because that would make my function have a domain value that's not allowed. Okay? So that's why you write that way. The domain is numbers that are less than negative 1/2 or between negative 1/2 and 3/2, not including those two numbers, and then 3/2 to infinity. Now, if you can't remember how to write it that way, you can just tell me x cannot be 3/2 and x cannot be negative 1/2, and I'll take that just fine. Just tell me what you know x can't be. That'll be okay. I just need to know that you understand what you can't do. The reason that's important is because that is where this function is going to have some asymptotes. Vertical asymptotes go up and down. Horizontal asymptotes go back and forth. Vertical asymptotes are where x can't be 0. Where x can't be, whatever that value is, where the denominator can't be 0. So its vertical asymptotes are at x equals negative 1/2 and at x equals 3/2.
I think I need you to back up and explain to me why x can't be 3/2 and negative 1/2.
So that's where it equals 0.
Because that would make this quantity in the denominator equal 0. Okay? That would make your denominator equal 0, and then your calculator is going to come back and say, no, you can't do that. In fact, we're going to graph it anyway, so let's just look at that.
So the quadratic formula that we did with all the steps was telling us which would make that function equal 0.
Yes.
Okay.
Yes. Okay? So if we try to plug that function in, and this one's a complicated one to put in your calculator, you have to put parentheses around your numerator, 5x minus 2, and divide it by that 4x squared minus 4x minus 3, and close parentheses on that. And we'll just go, once again, we'll go with zoom 0. I'm sorry, zoom 6. Now, that function looks really odd because you've never seen one that does that before, but that's because it's trying to connect up its dots. So I'm going to go and change the mode of the calculator and tell it, instead of trying to connect up all the dots, don't connect all the dots. Just plot the points. Don't connect up everything. Just plot what's on the function. And now here's what you see. So what it's telling me in that graph, let's see if I can go ahead and sketch it for you over here. This is what's happening. Here's my x-axis. Here's my y-axis. X equals -1/2. Since most of the interesting stuff on this graph goes really close to the origin, I'm going to call this -1, -2, -3, and 1, 2, 3. At x equals -1/2, at x equals 3/2, that function can't touch those two places. And the easiest way for me to plot this graph is to actually go to the calculator's table and let it help me. So what I'm going to do is I'm going to go, first of all, second window, and go over to ask for your table, and then go second graph and ask it at -3, -2, -1, 0, 1, 2, 3. What is that function doing? And I see at -3 it goes down, and again I'm going to just go like this.
So how did you get
To the table.
to that? Yeah.
You get to table by hitting second graph, but you set it up to ask, not auto.
I had already asked.
Okay? And it says that when I'm at -3, I'm only about a third down. So that's about here. And when I'm at -2, I'm a little more than a half down. And at -1, I'm about 1.4 down. So what it's doing is it's going like this. And then on the other side, it's doing kind of the same thing. It's going, let's see, at 0, it's at 2/3. At 1, it's at -1. So it's doing like this. So that's really what your graph looks like. Your calculator's not doing a real good job of showing that to you. Okay?
So for this one, then the range, okay, so I'm confused now.
The range on this one, the range is still negative infinity to infinity.
Okay.
Yeah, because it can still keep going on up, it still keeps going on down, because notice here, it still goes up.
Yeah.
And down here, it still goes down, so there's no restrictions on the range,
Well,
just the
when I
domain.
did the min, or, yeah, when I did my min, up to 100, it actually would, it ended up showing it.
So when we.
I'm sorry, I messed up here.
For the second part with the x-intercept and the y-intercept, and we still follow the same.
Yes, the y-intercept actually you can find, I found it by looking at my table. My y-intercept is 2/3. And if you want to put 0.67, that's fine. X-intercepts, it doesn't have any.
Right.
Okay? Now, when it asks about the horizontal asymptote, notice that all it's doing here is it's going out flatter and flatter and flatter and flatter this way. So its horizontal asymptote is the x-axis. So where does y, it's y equals 0 is its horizontal asymptote. Because it just keeps hugging up against the axis, but it never touches it.
So what was the y-intercept on it?
The y-intercept is 0 2/3, and you get that off the table. Or you can go and ask the calculator, where is x equal to 0, and it'll tell you.
You bring that up in front of me. I didn't get actual order lines.
Bring it back in.
There are no x-intercepts, but the y-intercept is 0, 0.67 or 0, 2/3.
So why is there no x-intercepts?
Because it can't touch the x-axis. You can let x go and go and go and go in both directions. And if you look on your calculator,
Wait,
you'll...
but doesn't the line in the middle intersect that?
Oh, yes, you're right. I'm sorry. Yes, it does. I forgot about this one. And you would find that one the same way that you find the others. You can do,
So if the x-intercept isn't?
let's see. No, it isn't none. You're right. I'm glad you noticed that. Let's go to second trace and find number 5, the intersect. And just hit enter. And there it is. So yes, it does have,
It has one.
it has 1.
Okay.
Thank you, Tanner. Because I forgot about the one in the middle. I was more worried about telling you about how I can't touch it on the outsides. But what you can do if you want to see why that's the,
When I do the second trace, it's not letting me find the intersect, like I'll click.
do you have y equals 0 for your second equation?
I do not, do I have to have that?
Yeah, you have to have that if you want to do intersect. You have to have the equation of the y-axis. Hmm? It's 0.4. It's 0.4.
And how do you find that? Your second trace.
In order to use the way I did it, you have to have y2 equal to 0. You have to have the equation of the y-axis. And then you can find where they intersect. Okay? Now, go ahead for yourselves. This one is a much easier version of what we just did, because it's not nearly as hard to figure out where that's going to be 0. That's going to be if x is equal to 3, there's a problem. So go ahead and try to work on that one, and then I'll record that one, and I'll record this one.
So is the exam gonna be kind of like this
Yes.
study guide? or
Yes, very
similar?
much like the study guide.
Now, do we bring in our own formula sheet, or are we given one?
You are given a formula sheet, and the formula sheet that you're going to have, so you'll know what you'll have, is actually, I'm looking for it right now. It's actually already in D2L, and I think I put it to show you, but if I didn't, I will. I don't see it, but it's actually there. You've got a copy of it.
I have a question about this, 'cause
About which? About something you got there, or?
yeah,
Okay.
the notes for the.